Imagine you are navigating a complex maze. Suddenly, a wall appears where there was none, blocking your path entirely. What do you do next? Do you just stop, or do you have a plan to reroute? In the world of computer programming, this unexpected wall is much like an exception, a signal that something has gone awry. When an exception is thrown in a computer program, the normal flow of execution immediately stops. The system then attempts to find a piece of code specifically designed to handle that particular type of problem. This search involves unwinding the call stack, looking for an appropriate exception handler. This immediate halt and search process is crucial for maintaining program stability and integrity. It is like an emergency brake being pulled, preventing further damage or incorrect operations. The underlying mechanism involves the runtime environment examining the active function calls, moving backward through them one by one. Each step backward is called stack unwinding. It searches for a block of code, often marked with keywords like try catch or finally in many programming languages, that is prepared to intercept and manage the exception. This ensures that errors are not simply ignored, but are instead acknowledged and potentially resolved or reported. To understand this process, think about how functions call each other. When function A calls function B and function B calls function C, a stack of these calls is built. If an exception occurs in function C, the system first checks C for a handler. If none is found, C exits abnormally, and the system then checks B. This continues until a handler is located or until the initial entry point of the program is reached. If no handler is found anywhere along this chain, the program will typically terminate, often displaying an error message known as a stack trace. An interesting detail is that even if a handler is found and the program continues execution, any resources opened by functions on the unwound stack might not be properly closed without specific care. This is where a finally block comes into play, as it guarantees execution regardless of whether an exception was caught or not. This is a powerful feature for ensuring resource cleanup, such as closing files or network connections, which is essential for robust software. The exception object itself carries valuable information about what went wrong, including the type of error and where it occurred, acting as a detailed report for the handler. Ultimately, understanding the journey of an exception from being thrown to being handled or causing termination helps you write more resilient and reliable software. By anticipating potential issues and providing structured ways to deal with them, you create programs that can recover gracefully from unexpected events, providing a much smoother experience for anyone using your applications.
If this helps you fix faster, like, subscribe, and keep debugging with us.